much. And first of all, thank you for having me here. And this is a presentation of preliminary and theoretical research. And from an idea I got when I saw this workshop coming, so I was to try to propose and show it. The idea behind is to study how the innovation, which is an increase in the technological level, in a simple socio-ecological system, could actually influence the systemic risk, and to develop a simple model in order to show if this could have maybe a non-trivial effect and something interesting can come out from it. The idea behind is this one. If the better technological level in a very simple socio-ecological model could actually affect the systemic risk. More specifically, the model that I developed and I studied and explored, also if not in a very deep way for now, is the following. The idea behind is to study just a population level which grows related to the number of calories available. And these calories, the level of calories available are depending on the fertility of the terrain, which amount is fixed because the idea is to observe an isolated system, and the technological level, which is basically the ability of extracting calories from the ground. So the more calories are available, the more the population can actually grow. The point is to observe, to make a study on the effect of the technological level in three different experimental settings, which are with a constant fertility, so that with a fertility that does not change in time, with random fertility, which is changing in time, but not with status, just randomly sampled each time step, and with a dynamic and non-random fertility, which is as this picture is showing, is depending, can be eroded by the level of population. So in this third experimental setup, the higher is the population level, an higher population level implies a diminution in the fertility in time, and which can be compensated, at least at the beginning, from an endogenous growth, but until a certain level. So the metric I used to observe the diminution in the population, which is what I'm observing, if level of increase in the ability of extracting calories could lead to a higher fall in the population after a growth. And the metric that I used is actually the percentage difference between the maximum and the minimum after the maximum. And so to observe if this difference is actually high or low, and so to observe how big is the fall. The first experiment, which is the one in which the fertility is steady, is constant, basically is kind of trivial because this is the base case, and of course the dynamic is easy to observe. And when the fertility is beyond the technological level, is beyond a certain level, is a certain threshold, and so the level of calories that can be extracted for a terrain is enough, the population growth until an equilibrium. Otherwise, they decrease until a certain equilibrium, which is, of course, it derives from the amount of calories extractable from the terrain. The second experiment on the other side implies the introduction of a random fertility, and so I study with a comparison with the variance of the random fertility, which actually was modeled by a random normal, and the technological level. And it was possible to observe that the higher the variance and the higher the systemic risk. But on the other side, in this case, an higher technological level, so an higher ability of extracting calories could mitigate actually this effect. On the left, there's an left side of the slide. You can see an heat map which map the metric for both variable, and on the right side, 2 examples, 2 runs of the model with medium variability and high variability. And the third and last experiment is an experiment in which the fertility actually depends on time and can be consumed and can grow again. And in this case, it was studied with a low fertility consumption for each individual, so for each unit of population, and high fertility consumption for each unit of population. And in this case, we found on the right side, you can see the behavior of the system at the population level. On the left side, the value of the metric for each technological level and for the fertility consumption per individual. In this case, except for very low values of technology, the higher is the technological level, the higher the ability of extracting calories from the ground. And also the higher is the fall of the population. So basically, in this case, increase in innovation in technologies could bring to higher fall and worse decrease in population and worse effect on the whole system. And so that actually was the presentation. As I stated at the beginning, is like a preliminary work. And there are some more investigations that could have been done, including, but not exclusively, with a study in a more deep way the dynamic of the model, increase the level of adherence to the reality, because this is very simple and very abstract, and then possibly observe the effect of individual attitudes and behavioral adaptation on the same problem, for example, by developing an agent-based model. And thank you very much for your attention. That's all.